the value on your numerator, but we just focus on denominator. So for this kind of fraction, okay, we have s plus c and s plus d, so that we can just divide into two parts, a over s plus c plus b over s plus d, but we ignore the value on your numerator. Okay, the second one, repeated linear factors. So this repeated linear, repeated to the power of n. So what you can do, a1, a2 until an, okay, over s plus c, meaning that repeated denominator. So you repeat until n. Depends on what is the value here. If the degree is 3, for example, so you can stop until 3 and so on. The third one is quadratic factor. So quadratic, so that it is in form of ax, here is as, plus b over as plus c, and then you have squared, okay, for the s. Okay, compared to repeated linear factors, for repeated linear factors, you have the power, so s in the bracket is to the power of 1, but the power is out of the bracket to the power of n, but in this case you have s to the power of something. Okay, so for this part, a over s plus c plus bs plus c over ds squared plus es plus f. Okay, yes. I'm not sure your module still in X. Okay. And then repeated quadratic factors. Okay. As repeated quadratic, repeated quadratic factors. Okay, here quadratic, and then after that repeated quadratic factor. Okay, so it has both both to the power of s and also the power of factor here. So you can use repeated quadratic factors. So the first one linear, okay, linear, and then the second one repeated here, repeated, and then quadratic, and then repeated quadratic and repeated. Okay. If you look at example 4.22, okay, and this is quite simple, but do you have pen and pencil and paper with you, or pen and paper with you?
Ada, Doktor.
Let's go for example. Let's go and try example 4 point berapa tadi? 4.22. 4.22. So this example, look at the equation, find inverse ILT for s over s squared minus S minus 6. Okay. So the first one, okay, S squared minus S minus 6, okay, you can factorize denominator. So when factorize this, you will get S over S minus 3S plus 2. So this is a linear case 1, linear factors, and then equal to A over S minus 3 plus B over S plus 2. Okay. Have you taken engineering maths 1? Have you taken yet? Or dapat credit exemption? Oh, saya lupa nak
Dapat credit exemption.
Right. Record Saya lupa pula record. Okay. So this inverse Laplace transform using financial equation. Example 4.22. So based on this equation, okay, and then for A and B, for A, you look at denominator. Denominator should have S minus 3S plus 2. Here S minus 3. So you need to multiply, cross multiplication here. So A multiply with S plus 2 plus B S minus 3. Okay, so here is S. Okay, so for example, S equal to, okay, I would like to settle, meaning that to make B equal to 0, so S equal to 3, so that 3, this S equal to 3, 3 equal to A times 3 plus 2. For this part, 3 plus 2 equal to 5, so that A equal to 3 over 5. Then S equal to, here, minus 2. Why we choose minus 2? Because minus 2 plus 2 become 0, so that we can solve for B value. So S equal to minus 2, negative 2 equal to 0 plus negative 5 B. So that B equal to 2 over 5. Then S over S squared minus S minus 6 equal to, substitute back your A and B. Your A equal to 3.5, B 2.5. So 3 over 5 S minus 3 plus 2 over 5 S plus 2. So inverse Laplace transform for this equal to inverse Laplace transform on your right hand side. Yes. Okay. So become, for this part, you will get Okay. If you want to go in detail, inverse Laplace transform of 3 over 5 S equal to 3 over 5. Inverse Laplace transform of 3 over 5. Now S shift by 3. First or second shift property class?
First.
Is this first or second? First, okay, first, because we don't have exponential, so that this is first shifting property. Okay. So by using first shift property, so just add exponential. Your A equal to 3. So exponential 3 T. Okay. Okay, this part. Same thing. Inverse Laplace transform of 2 over 5s equal to 2 over 5, but inverse 2 over 5 s plus 2, it has shifting property, so become shifting. What is the value of A? A equal to negative 2, so negative 2t. Okay. So your final answer, you just combine. So ft equal to 3 over 5 exponential 3t plus 2 over 5 exponential negative 2t. Okay. You can also factorize by using 1 over 5. Also, you can do like that. Okay. Any question, class? No. Okay. Next.
Doktor, kan kalau yang ni kan, kalau contohlah saya ambil, saya jadikan dia S plus 3 instead of F minus 3, nanti final answer saya akan terbalik dengan final answer doktor. Maksudnya saya stay acceptable ke jawapan saya?
Meaning that macam mana?
Yang dekat bahagian atas ni, kalau kan
Ni.
instead of S minus 3, S plus 2, saya jadikan dia S plus 3, S minus 2 kan? Tapi outcome dia still sama, which is S square minus S minus 6 kan? So nanti
Tak.
kalau dekat final answer saya terbalik, still betul ke doktor?
Okay. S squared minus S minus 6. So you will get minus 3 and 2. But you use S plus 3, S minus 2 Macam ni?
Betul ada.
No, this one you will get S squared plus S minus 6. Sama tak? Alamak, ada orang drill pula. Betul tak? S minus 3, S plus 2, you will get negative 1S. But if you choose to use S plus 3, you will get positive 1. Faham tak maksud saya?
Faham doktor?
So, ada silap betul?
Betul.
Boleh pula lah ada drill. Okay. So we move to the next. This is case 1. Case 1. Apa dia tadi? Linear. Okay, then kedua, we go to okay, class. Try example 4.23. Since someone drilling on the upper level, so you can try first. Buat semua, someone drilling lah. Saya tahu level berapa ni. Buat dulu Okay, class. So we have s squared plus 5 over s plus 1 squared, and then s plus 3, okay, a over s plus 1 plus b over s plus 1 plus c over s plus 3. So compare, so s squared plus 5 equal to a multiply with, okay, s plus 1 and then we let off s plus 3 and then multiply with s plus 3 plus b s plus 3 plus c s plus 1 squared. Okay. Now as I prefer to start with s equal to -1 because I want to solve for this, and then a and c parts can be 0, become 0. So 0 plus b s minus 1 become 2b sorry, left. Minus 1 squared equal to 1 plus 5 equal to 6 equal to, so 0 plus minus 1 plus 3, 2b plus 0, so b equal to 3. S equal to minus 3. Okay, want to make it 0 for this part and also for this. So 9 plus 5, 14 equal to this part 0, 0. So S plus 1. Minus 3 plus 1 minus 2 squared 4. C. So C equal to 14 over 4 equal to 7 over 2. And then, so for this part, and then another one you can choose based on S squared, or you can choose constant. Okay, constant means S to the power of 0. You will get the same answer. Okay, so this, if choose S squared, it's like equating coefficient. Saya lupa sebab. Okay, like equating coefficient. So S squared on your left is 1 equal to, okay, S squared. On your right hand side, how do you know which is your S squared? So this part, S times S equal to S squared. So A, okay, for B, no, S squared, and then C. C, here S plus 1 squared means that you will get S squared for C. So A plus C. 1 equal to? A plus 7 over 2. So A equal to 25 over 2. Boleh? So inverse Laplace transform of S squared plus 5 over S plus 1 squared S plus 3 equal to inverse Laplace transform of A. Your A here, negative 5 over 2 S plus 1 plus B. B is 3 over S plus 1 squared plus C 7 over 2 S plus 3. So equal to the first one. The first one we use just now we have apa? 5 over 2 S plus 1. So the first step you need to find 5 over 2S. So you refer to this 5/2. So your A equal to 5/2 over S. So FT become 5/2. Ganggu tu 5/2. The first one is negative 5/2. Okay class, now you have S plus 1. First shift. So based on first shift, mana tadi? First shift. Saya tulislah. Okay. So you have first shift property. Okay. Inverse Laplace transform of a function f s minus a. So you will get exponential first shift 80 or negative 80. Allahu Akbar. First shift exponential 80 kan? Inverse of fs. So 5/2. So exponential, your a is 1 or minus 1. Minus 1 So this part a equal to negative 1. And then plus 3. Yeah. 3. Bisa kuat sangat tak you all dengar? Kuat sakit boleh. Okay. So for 3/s plus 1 squared. So inverse Laplace transform of 3/s squared, you can modify to inverse Laplace transform of 3/1/s squared. So equal to, for this part you can refer to this one. So we have 1 over ada tak? 3 saya salah sekejap. S plus 1 dia squared ke? Ada. Okay. 1, betul lah. S to the power of 2 Right. So become T to the power of 1, right? This is n factorial. So 1 factorial. Betul So you will get 3t to the power of 1. So 3t. Since we have first shift, so shifting here a equal to negative 1. So for shifting exponential negative 1t. And then the last one, plus 7/2 exponential, very simple, exponential negative 3t. Boleh Any question? Okay, we move next example. Boleh tak? And then after that we go to exercises 4.24. For case number 3, quadratic factor. So inverse Laplace transform of 4s squared minus 5s plus 6 over s squared plus 9. Okay, quadratic factor. So we have this part. Allah. Okay. So for quadratic, case number 3, quadratic factor. So 4s squared minus 5s plus 6 over s squared plus 9 equal to, ignore your numerator. You can ignore. Focus on denominator. So a over s plus bs plus c over s squared plus 9. Okay. Because you have s to the power of 2, so you need to have bs to the power of 1 on your numerator. So for s squared minus 5s plus 6 equal to, so your a multiply with this and bs plus c multiply with s squared plus 9 plus bs plus c multiply with s. So you can factorize based on s. So s to the power of 2. Okay, you have a s to the power of 2 times bs, okay, time plus, meaning that a plus b plus s. For s, we only have c, so cs plus, okay, s to the power of 0, so 9a. Okay. So look at here. Based on this, okay, for example, now you have look at the equation, you have a plus b, so you need to find two values, but cs and 9a, okay, cs, c standalone, meaning that there is no summation or subtraction for this part, meaning that compared to a plus b here, if you want to find based on s squared, okay, you need to know at least one, okay, one of these a or b. But in this case for s, you can use equating coefficient method. So c, and then look at on your left hand side, you have negative 5s. So you can get direct value here for s. Okay, on your left hand side, negative 5 equal to your right hand side is c. So your c equal to negative 5. Okay. And then for s to the power of 0 or constant, on your left hand side, a constant is 6, on right hand side is 9a. So your a equal to 6 over 9 equal to 2 over 3. Okay. And then the last one about a plus b. So about s squared. 4 on left hand side 4 equal to right hand side is a plus b. So 4 equal to a is 2 over 3 plus b, so that your b equal to 12 minus 2 over 3 equal to 10 over 3. Okay. Then inverse Laplace transform of the whole equation for s squared minus 5s plus 6 over s times s squared plus 9 equal to inverse Laplace transform of your a, okay, a over s okay, your a is just now your a 2 over 3 2 over 3s plus bs. B is 10 over 3s times s squared plus 9, okay, plus c negative 5. So negative 5 over s squared plus 9. Okay. So inverse Laplace transform for the first part, 2 over 3s become 2 over 3, no shifting, plus 10 s 10 over 3 s over 3 s over s squared plus, okay, class, once again, okay, I want to share to tell you for this part again, if you find that you have s to the power of 2 s squared in the bracket on your denominator, so your a here, okay, for this part must also in form of a squared. So 9 is equal to 3 squared. Okay. Over 5, minus 5 over s squared plus 3 squared. Equal to 2 over 3 inverse Laplace transform of 10 over 3 s over s squared plus 3 squared. Look at the table. S over s squared plus 3 squared, so equal to cos. Okay, cos 80, meaning that 3t cos 3t plus minus, okay, minus 5, okay. Can we straight away use this equation or we need to modify? we need to modify. Inverse Laplace transform of, okay, A is 3, so it must be 3 here. It must 3 over S squared plus 3 squared, and then 5 over 3. Okay. So 2 over 3 plus 10 over 3 cos 3t minus 5 over 3 A over A squared. Over A squared plus kan? Sin 80. So sin A is 3. Sin 3t. Okay. This is your final answer. Okay, so this is FT. Any questions so far, class?
Tak ada, doktor.
Okay, next example. (4.25) Inverse Laplace of S squared plus 2S plus 1 over S minus 3 S squared plus 4, okay, to the power of 2. Solution. So S squared plus 2S plus 1 over S minus 3 S squared plus 4 squared equal to A over S minus 3, after that, plus B S plus C over S squared plus 4 plus DS plus E over S squared plus 4 of 2. Okay. Now you use quadratic. So S squared plus 4 on numerator, your constant multiply with S plus another constant. Okay, same goes to this. Okay, but the power here depending on the highest power here. So to the power of 2, so it is repeated 2 times. Okay. 4.2, 4.24 dah belum? Dah ya, okay. 4.25 betul 4.25 then okay class. S squared plus 2S plus 1 equal to A. So minus 3, so multiply with this S squared plus 4 squared plus, okay, since you have this, you need to multiply a set of this with S minus 3. So BS plus C times S squared plus 4 S minus 3 plus DS plus E multiply S minus 3. Tak nampak lah E saya sekejap Okay. Okay, kelas. Continue. S squared plus 2S plus 1 equal to A S to the power of, okay, we solve for this. S to the power of 4 plus 8 S squared plus 16 plus BS plus C. So S cube plus 4S minus S pula, sorry. S cube minus 3S S minus 12 plus ds squared minus 3ds plus es minus 3e. Okay. So s squared plus 2s plus 1 equal to, okay, a s power of 4 plus 8s squared plus 16 plus okay, bs to the power of 4 plus c minus 3b s cube plus boleh? Boleh? Okay tak everyone?
Okay, okay.
Okay, based on your module okay, if you refer to the module, mana tadi? 25. Okay. For this part, okay, right, it does not combine. It also does not combine with this for s squared, for example, or s does not combine with this s. Why? Why, class? Plus 4b, okay, for s squared 4b, okay, minus 3 c s squared plus Okay. For S only. For C, and then 12BS. For C minus 12BS, and then minus 12C. Then plus DS squared plus E minus 3DS minus 3E. After that, we can go straight away to equating these coefficients. In this case, S squared plus 2S plus 1. So, Y, okay, this S, okay, does not combine with this S. Why, class? For B, B, do you have any idea? Then we go equating the coefficient. We use S minus 3. S equal to 3. Class, how do we know we can choose S equal to 3? How do we know this?
Yes, will become 0.
How do you know you will get 0?
S minus 3.
Yes. Okay. This will lead to the answer why you not combine this. Because here we solve for this to make this part 0. Okay. Or to make this part 0. Okay. For example, if you combine so that you will make this part mass together, so you will mess them up. So better to, meaning that you solve for this, and then for this part you not combine, meaning that you just solve by not meaning by part method. So this part, after that this part. Okay, please do not combine in this case, so that it is easier for you to choose which S you can choose to make your equation 0. So here is 3. So that if you have S equal to 3 on your left hand side, what will you get? 16. So after that you can just focus. Okay, focus on A. So equal to 169A. So your A become 16 over 1, 69. Okay. So for example, if you combine this, of course you combine for A parts together, right? So you will confuse which as the best to choose. Okay. Then next, S to the power of 4. So on your left hand side equal to 0. On your right hand side we have A. Then we have B. And then only these two, so B equal to negative A. Okay. So for S to the power of 3, left hand side 0, right hand side to the power of 3. C minus 3B. Okay. So C become your C. B is negative, right? So C equal to negative 48 over 169. Okay. Okay, I'm sure you know how to solve this. So S squared 1 equal to, look at S squared, you have 8A plus 4B minus 3C plus D. Okay, look at here. S squared, and then here S squared, and then plus D. So you will get your D equal to negative 3 over 13. Same goes to S. S to the S only, S to the power of 1. So 2 equal to S. So S have here and this part. So 4C minus 12D plus E minus 3D. So your E equal to 17 over 13. Okay. So S squared. So inverse Laplace transform of 16. Your ABC just now, 16 over 169 S minus 3 plus B. So B in negative value, BS over 169 S minus 3 minus C plus C. So C negative 48 over 169 S squared plus 4. So plus D. Plus D. So D, your D negative 3 over 13 S squared plus 4 squared plus E is 17 over 13 S squared plus 4 squared. So equal to 16 over 169 S minus 3 first shift. So exponential A equal to 3T minus 16 over 169 S over S minus 3 so plus, isi salah tulis ke? Salah tulis squared, S squared plus 4. So here is A equal to 2, so this become 16S over 169S squared plus 2 squared. So S squared, S over S squared plus 2 squared is, refer to table, cos 2t, okay, minus 48 over 169, okay. So for this part we cannot solve straight away. You need to modify. How to modify? How to modify? Inverse Laplace
24
transform.
times 2.
So 2 over 169 S squared plus 2. So times 24. 12 plus 24. Okay. So this part become 24 over 169 cos, so this is sine 2t. Okay. Okay, class, and then for this part, okay, we can solve for this square quadratic, but this is quadratic. After that, it has degree, repeated quadratic. So for, if you find out this case, you cannot use partial fraction, so you need to use convolution method. Okay, convolution method we will learn in next topic. So just leave it. Inverse Laplace transform of 3 over 13 s squared plus 4 plus inverse Laplace transform of 1713 s squared plus 4 power of 2. Okay. Okay, alright. So for these two, already mentioned in your module, need to use convolution. Okay, convolution theorem. Okay. Any question? If you have a question, okay, we move to exercise. Look at my battery berapa? 19. Okay, need to save it first. Today is 27. Exercise 4F. Try for B. B inverse Laplace transform 1 over S plus 10. Okay, and find inverse Laplace transform of exponential negative 2s over s plus 10. Okay. You may try. I give you 10 minutes. Okay. Okay. Have you got the answer? Class? Okay ke? Do you still with me, class?
Ada doktor, belum settle lagi.
Okay, doktor.
Equal to, so here starts with A over S,
S.
that B,
S
B
plus 10.
or BS. B ataupun BS? B
B saja.
Because denominator to the power of 1, so here the power of S to the power of 0 equal to 1. So 1 equal to A, S plus 10, B, S. So S equal to S equal to
0.
0 to make B is equal to 0. So 1 O equal to 10 A, so that A equal to 1 over 10. And then S equal to minus 10, you will get 1 equal to minus 10B. So B equal to 1 over negative 10. So Laplace, inverse Laplace. So inverse Laplace of 1 over S plus 10 equal to 1 over 10 inverse Laplace of, you start with
1
this.
over S.
Okay je, if you start with this pun just okay. 1 over 10 S minus, or you can write 1 over 10 inverse Laplace of 1 over S minus 1 over S plus 10. So for the first one, you will get 1 over S equal to 1, and then 1 over S plus 10 is 1, but S plus 10 first shift. So exponential T, because first shift A equal to negative 10, so minus 10. Ada siapa nak tanya tak? Okay. Alright. Boleh?
Boleh doktor.
Okay, complete dah semua yang ini. We go to the next. E, inverse Laplace transform of 20s over s squared plus 9. Okay, try. Okay, class? Dapat? For E, so we start with 20s over s plus 49 s squared plus 9 equal to, okay, how can we convert? So what should we have on our right hand side? Over s squared plus 49 and then plus over s squared plus 9. What is our value here? What is the value here, class?
AS plus B.
Why as plus b, not a only? Why?
Because the power of S at the denominator is power of 2.
Okay, very good. So as plus b. So for this,
CS plus D.
yes, correct. Cs plus d. Okay. So 20s equal to as plus b multiply s squared plus 9 plus cs plus d so s squared plus 49. So as to the power of 3 plus bs squared plus 9as plus 9b plus cs cube plus ds squared plus 49 cs plus 49d equal to okay, for s to the power of 3 you can combine because in this case we have s squared, so we can combine everything and then we go for equity and cohesion based on the power of ds. Okay, so a plus c plus 4s squared b plus d plus 9a plus 49c s plus 9b plus 49d. Okay. So look at the best or the easiest way or the fastest way that we can get our constant here. So look at here for here we have A and C. So for this part, okay, S cube on your left hand side equal to 0. On right hand side we only have A plus C. So that we will get A equal to negative C. Okay. Or vice versa, is up to you. So maybe I can just leave it like A plus C, and then for S squared, left hand side equal to 0, right hand side is B plus D. Okay. Now for S, left hand side is equal to 20, on right hand side is 9A plus 49C. We know that A equal to negative C. Okay, so 20 equal to negative 9C plus 49C. So equal to negative 40C. So C equal to negative positive. Oh, sorry, positive. It's positive. Negative. Positive. C equal to 1 over 2. Since C equal to minus A or A equal to minus C, okay, so A equal to negative 1 over 2. So for S to the power of 0 or a constant, on left hand side is 0, right hand side is 9B plus 49D. We know that B equal to negative D. Okay, so 0 equal to negative 9D plus 49D equal to 40D. Okay, so D equal to 0. Since D equal to 0, your B also equal to 0. So you have few values here. A, B, C, D. Continue. So inversion of 20s over s squared plus 49 s squared plus 9. So equal to your A just now, negative half. So negative 1 over 2. But your A has S, right? Okay, so s squared plus 49 plus your B is 0 plus C. C is
1 over 2.
Yes, 1 over 2 s squared plus 9. Does your C has S? Yes. And then plus 0. So here you will get 1/2. You can move this half outside. So s over s squared plus 49 plus s over s squared plus 9. So this you need to change to 1/2 inverse Laplace transform of s over s squared plus 7 squared plus s over s squared plus 3 squared. So what will you get later for your answer? So s over s squared plus a squared. Look at your table. S over s plus a. This one cos. Okay, cos 80. So cos 80. Cos your a is 70 plus also cos 80. A is 3. Okay, betul tak? Atau terbalik?
Betul.
Ada negatif. Betul lah?
Negatif. Betul.
Or you can write lah 1/2 cos 3t minus cos 70. Okay. Nak tengok berapa persen I punya iPad ni sekejap 3%. Okay kelas. Since 3% left. Okay. Any question? Any question?
Doktor, macam mana kita nak determine kita kena guna apa? Equating equation
Okay. For example kan. Okay. Memang kenalah. There is a kind of method under partial fraction for this part Ni equating coefficient S. Sebab all of this S. And then this also for 49D kan, also we can consider as equating coefficient, but for X, not X, for S to the power of 0. Ni, a constant. Okay, so kalau menjawab ke? Ataupun soalan awak yang
soalan saya macam mana kita nak determine kita kena guna method tu ke tak
method yang ini?
Yang apa macam nak pronounce ni? Co-weighting efficient.
Equating.
Macam mana kita nak determine whether soalan tu kena guna method tu ke tak?
Okay, before that I will ask you how to get this. A, B, C, D. Do you have another method? Maybe you can share with us. Macam mana nak dapat ni? A, B, C, D. Ada tak cara lain?
Tak ada.
Cara yang nak gunakan ada cara begini, betul tak?
Betul, doktor.
So if you find out that you have S to the power of 3, 2, macam ni kan. So you need to use equating coefficient ataupun in simple words. Okay, you compare your left and right hand side. You compare your S on your left and then compare on your right hand side. Compare pun, okay, simple word. Okay, so compare left and right. Okay, so S here, compare with S on your right hand side. So this is S on your right hand side. And then S to the power of 3, okay, on your left hand side, no value. So put it as 0. Boleh tak macam tu?
Dapat, doktor.
Okay. Any other question? Okay. So that class, our class dismissed here. See you on next week on Tuesday. Alright. Thank you. Assalamualaikum. Selamat Hari Raya. Maaf zahir batin.
Salam doktor, terima kasih.
Terima kasih doktor. Selamat Hari Raya.
Selamat Hari Raya.
Thank you, Doctor.
Terima kasih doktor.
Thank you, madam.
Welcome.
Thank you, madam.
Terima kasih, madam.